We live in a universe of stunning beauty. Throughout human history, people have wondered, why does this breathtaking universe exist? Why is the cosmos here? Why are we here? Has the universe always existed, or did it have a beginning? And if it did have a beginning, was a creator involved? Or did the universe somehow form all by itself? The Bible says that the Lord created the universe for His own purposes and His own glory. It describes a creation event that no human was around to see, but if there were humans on Earth back then, they would have seen this creation occur just a few thousand years ago. But this is not what many scientists believe today. The majority view today among secular scientists is that our universe formed itself in a Big Bang event about 13.8 billion years ago. In this video, we'll examine the Big Bang model to see whether or not this model actually fits the universe we live in. We'll discover that in spite of the opinions of secular scientists, the Bible is by far the superior explanation for our created universe. I'm Spike Passaris, your host. This is the third volume of the What You Aren't Being Told About Astronomy series, and it's about the biggest topic of all. The Big Bang model is a theory of everything. It's supposed to explain where the entire universe came from. And since the universe contains everything that can ever be perceptible to us, the Big Bang model, therefore, is supposed to explain why everything exists. But just how good is this model? In this video, we'll look at the Big Bang model. We'll see that it's not as good of a theory as you've been told. We'll see a lot of evidence that is inconsistent with the Big Bang, but quite consistent with the biblical description of the heavens instead. The Big Bang is a very popular idea today. There are even many Christians who believe that God used the Big Bang to create the universe. They do this because they've been told that the Big Bang is good science. But as you'll see in this video, the Big Bang is actually not good science, and Christians are under no obligation to accept it. Nevertheless, there are some Christians who believe that God created the universe in some sort of Big Bang event. This belief is misguided, and I've written more about this at creationastronomy.com. For now, keep in mind that in this video, when I talk about the Big Bang, I'm talking about the secular idea, that the universe created itself in the Big Bang, with no creator being involved. In previous volumes of this video series, we looked at the secular explanation for the origins of our universe. We saw that supposedly, the universe is about 13.7 to 13.8 billion years old. Supposedly, in the beginning, there was nothing, and then suddenly, there was something. The universe burst into existence in an event now known as the Big Bang. At first, the universe was filled with radiation, and then as it expanded and cooled, matter began to form as gas. This gas was about 3/4 hydrogen and 1/4 helium, with maybe trace amounts of lithium and beryllium, but nothing else. As time progressed, this gas started to clump together to become the first stars. These stars clumped together to become the first galaxies. As billions of years passed, other stars and galaxies formed. One of them was our own Milky Way. Within the Milky Way, a smaller cloud of gas collapsed, which formed our solar system. And within the solar system is the planet Earth, where we are today. In the first volume of this series, we looked at the origins of our solar system. We saw that this part of the model has many major problems, as it can't account for many of the solar system's characteristics. Indeed, it says that many of the planets shouldn't exist at all. In the second volume, we looked at earlier stages of the model, the formation of stars and galaxies. Again, we saw that the secular model actually can't explain the contents of the universe, because it has no way to account for the formation of the first generation of stars. In this volume, we're going all the way back to the beginning and examine the Big Bang itself. We'll see if this part of the model is any better than the later parts. We'll dig deep into the scientific literature and talk about things that few non-cosmologists know about. Also, this video will be about the creation of the universe, but obviously there aren't any photographs of this event to look at while we're talking about it. So for most of this video, we'll see lots of pictures of the contents of the universe today instead, some of the most beautiful objects that God has made. So here's what we'll do in this video. First, we'll look at the Big Bang model, and we'll examine the evidence that is offered to support it. We'll discuss why secular scientists claim that this theory is good science. Then we'll look at several reasons why the Big Bang is actually bad science. It turns out that a closer look at the evidence actually discredits the Big Bang instead of supporting it. After that, we'll go even further and look at the full implications of the Big Bang model. We'll see that not only is the Big Bang not good science, It's not even bad science. It's actually anti-science. When taken to its logical conclusion, the Big Bang model makes science itself impossible. So if science is a valid way to discover how the universe works, then the Big Bang model must be false. Now that's a pretty bold statement. So let's get started. When we look out into the universe, it's easy to wonder, why is it here? The Bible says that the universe is here because God created it, as described in the first verses of Genesis. In the beginning, God created the heavens and the earth. The Bible describes how the creation occurred over 6 days. The earth was created first, and then on day 4, the sun, moon, and stars were created. Of course, this explanation for the universe is not the one you'll hear endorsed in science programs, textbooks, and so on. In fact, in our society today, we're often told that it's illegitimate to try and use the Bible to understand the history of the universe, because the biblical account of creation is supernatural. The prefix super means above or beyond. Therefore, something that is supernatural is that which is above or beyond the natural world. And many scientists today insist that only natural explanations are allowed in science. Now, previous generations of scientists didn't think this way. In fact, most of the giants of science, great scientists like Kepler, Newton, Euler, Pasteur, Faraday, Maxwell, and many others, all believed strongly in the Bible and in the biblical account of creation. They saw no problem doing science with the biblical outlook. Nevertheless, the reigning outlook in science today is naturalism, the idea that only natural explanations are allowed. For example, the University of California at Berkeley has a website called Understanding Science that explains it this way. Modern science does not deal with supernatural explanations because they are not scientifically testable. In other words, there's no way to gather evidence that would help us determine whether or not the explanations are accurate. We're told that the biblical account of creation doesn't meet this standard, and so it's disqualified. In fact, we're told that we don't need the creation account anyway, because we have a natural explanation for the universe, the Big Bang model. And we're told that this explanation is based on good science. But is it really? Let's take a look. The Big Bang model is based on 3 primary lines of evidence: redshifted light from faraway objects, the abundance of light elements in the universe, in other words, the amount of hydrogen, helium, and lithium that exists, and finally, the cosmic microwave background. Now, some of those concepts might be unfamiliar to you, so let's go through them briefly. When we look out into space, outside of our Milky Way galaxy, we see lots of other galaxies, and we've discovered something very strange about these galaxies. Except for a small number of galaxies that are fairly close to us, all the rest emit light that is redshifted. And it appears that the farther away they are, the more redshifted their light is. Here's what it means for light to be redshifted. You're probably familiar with the idea that if you take a beam of white light and shine it through a prism, the prism will break up the light into the various colors that it contains. Astronomers have instruments called spectroscopes or spectrometers that do similar things. When you analyze sunlight with one of these instruments, you'll see a pattern that looks like this. Notice that sunlight contains a wide spectrum of wavelengths or colors, all the way from red to violet, all the colors that the human eye can see. But notice also that in a few places, there are some specific colors missing. These are called absorption lines. What's happening here is that the sunlight has to pass through the sun's atmosphere on its way to us, and certain elements within the sun's atmosphere absorb specific colors as the light passes through. So those colors are missing from the sunlight. It turns out that each element absorbs its own set of colors. So by looking at the set of absorption lines within sunlight, we can actually measure which elements are within the sun's atmosphere. When we look at sunlight, we see a spectral pattern that looks like this. But here's a second spectral pattern from a distant galaxy. Notice anything about it? You can see that the elements in the sun's atmosphere make a distinctive pattern of spectral lines. You can also see roughly the same pattern in the light from the distant galaxy. So that tells us that the stars in that galaxy are made up of roughly the same elements that the sun is. But notice also that the patterns don't line up exactly. The spectral lines from the distant galaxy are shifted toward the red end of the spectrum. This is called a redshift. Light gets redshifted when the object that's emitting the light moves away from the observer. You can think of it as the light waves getting stretched out. On the other hand, light can also be blue shifted when the object emitting the light moves toward the observer. You can think of it as the light waves getting bunched up as they travel. We see then that we can measure starlight from distant galaxies and see if it's redshifted or blue shifted. If it's blue shifted, the galaxy is moving toward us. If it's redshifted, the galaxy is moving away. And it turns out that except for a few close-by galaxies that are blue-shifted, every other distant galaxy we can see is red-shifted. In other words, except for a few close neighbors, every other galaxy we see is moving away from us. And it appears that the farther out a galaxy is, the more red-shifted its light is. In other words, the more distant galaxies are moving away from us faster than the ones that are closer. This discovery was a real surprise. There are several possible ways to interpret it, but secular astronomers choose an interpretation that's now called the cosmological principle, or sometimes the Copernican principle. This idea says that any observers in the universe would see the same things from their perspective as we see from ours. In other words, no matter which galaxy you happen to be in, you would see all the others rushing away from you, just like we see from our vantage point in the Milky Way. Now imagine what this means. If all the galaxies are moving away from each other, then the universe is expanding, and it's getting bigger as time goes on. The opposite is also true. If galaxies are moving farther away as time goes on, this means that they used to be closer together in the past. If you can mentally run the movie backwards, you'll see that eventually you reach a time when all the matter in the universe was at the same place. And this idea is the basis of the Big Bang model. The Big Bang model basically says that all the matter, all the physical stuff in the universe, started out compressed into an extremely tiny point in space. And not just the matter was compressed, the entire universe, all of space itself, was compressed into a single point. Then it suddenly exploded outwards, and that outward motion continues until this day, although the rate has changed somewhat over time. This is supposedly why we see all the galaxies still moving away from each other today, because space itself is still expanding, and carrying all the galaxies along with it. And this is the first of the three main lines of evidence that are thought to support the Big Bang model. Red-shifted light from faraway galaxies would indicate that they're all moving away from us as time goes on. And if you mentally run the movie backwards, you can imagine that everything started out at the same place, which was the Big Bang. The second line of evidence comes from the amount of light elements, hydrogen, helium, and lithium, in the universe. Secular astronomers have tweaked the Big Bang model to a point where it can supposedly account for these elements in the same concentrations that we see today. The third line of evidence is based on a prediction made back in the 1940s and 1950s. Back then, a few astronomers had realized that if the Big Bang were true, we should see leftover low-temperature radiation from it. Radiation matching this description was found in 1964, and it turns out that there's microwave radiation coming to Earth from all directions in space. This is now known as the CMB, or the cosmic microwave background. This radiation is at almost exactly the same temperature everywhere, regardless of the direction it's coming from. This sky map shows the temperature variations, which are tiny. The color differences represent variations of less than 1,000th of a degree. We'll see later why this is important. Anyway, the discovery of the CMB was the crowning glory of the Big Bang model. Other secular cosmologies of the time were quickly abandoned, and the Big Bang became the dominant model among secular astronomers. After all, the model not only matched the known evidence, cosmic redshifts, and the abundance of light elements, it also made a prediction that was then supported by later observations. Most secular astronomers today believe that this proves the Big Bang model to be correct. But there's more to the story than this. Much more. Let's move on to our discussion about why the Big Bang isn't actually a good scientific model after all. To assess the validity of the Big Bang model, we need to examine it in a little more detail. Let's start at the beginning. The Big Bang theory says that in the beginning, there was nothing. Then it exploded. What exploded? Nothing exploded. How can nothing explode? Big Bang believers explain that nothing can explode and does. In fact, nothing did explode and made everything. That's why there's everything instead of nothing, because nothing exploded and created everything. There, see how easy that is? Of course, saying that nothing created everything doesn't work. Nothing can create nothing. Nothing can do nothing. From nothing, nothing comes. As R.C. Sproul once said, if there was ever a time when there was truly nothing, there could never be anything. And as Dr. Phil Fernandez once said, you can't tell me that nothing made everything. I know too much about nothing. If you ask a secular cosmologist about this, some will just shrug and say that the question of what existed before the Big Bang is meaningless, because time itself didn't exist before the Big Bang. So we can't ask about conditions before the Big Bang, because there was no before the Big Bang. There was no then. As a Harvard astrophysicist explained, What came before the Big Bang might well be a meaningless puzzle, since at the beginning of the universe, matter, energy, space, and time probably all came into being. The concept of time before the Big Bang is quite possibly nonsense. To most cosmologists, asking what happened prior to the Big Bang is akin to asking what lies north of the North Pole. In other words, we aren't allowed to ask how the Big Bang could have happened, because it just did. The Big Bang happened because it happened. And since there was nothing that could have created the universe just created itself because it created itself. That's not good reasoning, though. Something can't create itself, because in order for the something to do anything, it must first exist. Self-creation would mean that the universe would have to exist before it existed, which is obvious nonsense. Sometimes you'll hear people say that yes, the Big Bang was extremely improbable, but if you wait long enough, even events that are extremely improbable will eventually occur. Well, that doesn't work either for two reasons. Number one, self-creation isn't improbable, it's impossible. It doesn't matter how long you wait, the impossible still won't happen. Number two, even if it were just improbable, it still doesn't work, because the Big Bang model says that time didn't exist before the Big Bang. So you can't wait long enough for an improbable Big Bang to happen, because you can't wait at all. There was no time within which to wait, nor was there a place to wait. Despite all this, some cosmologists still try to justify the Big Bang anyway. For example, famous astrophysicist Stephen Hawking has claimed that gravity is responsible for the Big Bang. Quote, "Because there is a law like gravity, the universe can and will create itself from nothing. Spontaneous creation is the reason there is something rather than nothing, why the universe exists, why we exist." He explained further, "The laws of gravity and quantum theory allow universes to appear spontaneously from nothing." Notice how he said universes in the plural. We'll talk more about that later. For now, notice what Professor Hawking is saying here. He's saying that the laws of physics are responsible for the universe creating itself. Is this a good explanation? No, for several reasons. First of all, the laws of physics don't actually allow universes to create themselves. We'll talk more about this in a moment. Second, the idea doesn't even make sense. What is a law of physics anyway? What does a law of physics look like? What does it sound like? What does it feel like when you hold one in your hand? Obviously, these are all ridiculous questions. The laws of physics are not physical things. So what are they then? Laws of physics are patterns that we've observed about how the universe works. For example, if an object is held above the earth and then released, it will fall, and it will do that over and over again each time you repeat the experiment. Because it does this consistently, we can measure how it happens and then describe it mathematically, as Isaac Newton did when he first wrote down his formula for gravitation. But again, this formula is not a physical thing. It can't create anything because it's merely our description of how the universe works. It's merely our description of the universe's pattern of behavior. Now let's apply this to the Big Bang model. According to this model, before the Big Bang, the universe didn't exist. Well, if the universe didn't exist yet, then its patterns of behavior didn't exist yet either. So they couldn't have been involved in the universe's creation. And so, secular cosmologists are still left with no way for the universe to create itself from nothing. And so, to avoid this, many cosmologists are now redefining the meaning of the word nothing. Secular cosmologists will still insist that the universe was created from nothing by nobody. They even write books about it. But when you dig a little deeper, you discover that when they say nothing, they sometimes don't mean nothing. Some cosmologists claim that before the Big Bang, there was a quantum vacuum field that fluctuated, and it made a particle pop into existence, which then grew explosively and became our universe. But there's a problem here, which you might have noticed. If the Big Bang was a fluctuation in a quantum vacuum field in space, then the universe didn't really come from nothing. It came from a quantum vacuum field, and a quantum vacuum field is not nothing. Even many secular scientists have complained about this inconsistency. As one physicist has said, a more fundamental problem is that this scenario does not really explain the origin of the universe. A quantum fluctuation of the vacuum assumes that there was a vacuum of some pre-existing space, and we now know that vacuum is very different from nothing. Vacuum, or empty space, has energy and tension. It can bend and warp, so it is unquestionably something. And famed cosmologist Alan Guth wrote, "From the point of view of general relativity, empty space is unambiguously something. According to general relativity, space is not a passive background, but instead a flexible medium that can bend, twist, and flex. A proposal that the universe was created from empty space seems no more fundamental than a proposal that the universe was spawned by a piece of rubber. It might be true, but one would still want to ask where the piece of rubber came from. So all that's happening here is secular cosmologists are just substituting one problem for another. To explain the universe, cosmologists are invoking a pre-existing quantum field. But they offer no explanation for the quantum field itself, or where it came from, or why it would even obey laws of physics from a universe that didn't even exist yet. So they say the universe came from nothing, but when they say nothing, they actually mean something, without explaining where this nothing that is really something came from. Some cosmologists try to cover this problem up. For example, Lawrence Krauss in his book Universe from Nothing tries to justify the nothing that is really something by claiming that a quantum theory of gravity is responsible for the universe creating itself. Notice that Stephen Hawking did the same thing earlier, when he also said that quantum gravity allows the universe to create itself. But there's a serious problem here, which they aren't telling you about. Physicists don't actually have any good theories of quantum gravity. A valid theory of quantum gravity does not exist. And these scientists are fully aware of this fact. As Krauss himself admitted in an interview, "I also don't have a quantum theory of gravity, so I can't tell you for certain how space comes into existence." So even though some cosmologists claim that the laws and theories of physics would allow our universe to create itself, this claim is false, as they themselves admit. In addition to not actually being allowed by physics, the Big Bang model goes much farther and also violates some of the most important laws of physics. Probably the most fundamental idea in physics is that energy and matter are conserved. In other words, energy and matter cannot be created nor destroyed. Physicists have known for some time now that energy and matter are interchangeable. For example, you've probably heard of Einstein's famous equation E equals mc squared. The E stands for energy, m stands for mass, which is the amount of matter or physical stuff, and c is the speed of light, which is a very large number. So a lot of energy is contained within a small amount of stuff. And we can convert matter to energy. The most efficient way we know how to do this is in a nuclear explosion. A small amount of stuff releases a tremendous amount of energy. We can also go the other way and convert a lot of energy into a small amount of stuff. We do this in particle accelerators. Tiny particles get accelerated to almost the speed of light and then get smashed together. More material comes out of those collisions than went in. The particles' kinetic energy, the energy contained in their motion, gets converted into matter. So again, we can convert matter to energy and energy to matter, but we can never destroy either one, and we can never create either one. This is called the law of conservation of mass energy, because the total combined amount of mass and energy in the universe never changes. We can only convert them back and forth. This law is one of the fundamental, foundational laws of science. As one of my physics textbooks says, conservation laws are the guiding principles of physics. These are absolute conservation laws. They are always obeyed. We see this law's effects every day in our lives. Why do you need to eat food? Regardless of how difficult that task may sometimes be. Because your body can't create energy from nothing, so it needs to get it from the chemical energy stored in the food. Why do you need to pump gas into your car? Because your car can't create kinetic energy, the energy of motion, from nothing, so it needs to get it from the chemical energy stored in the gasoline. Why do you get a bill from the electric company every month? Because the electrical devices in your home can't create energy from nothing, so they have to get it from the electric company, which also can't create it from nothing. It gets it from coal or natural gas or some other source. In fact, you couldn't be watching this video if this law weren't true, because you're watching it on an electronic device, and some of the principles of electronic circuit design are based on this law. Again, this law is very fundamental, but the Big Bang model violates it on the largest possible scale, a universal scale. It says all the energy and matter contained in the entire universe was created from nothing. Therefore, the Big Bang contradicts physics in the most fundamental way possible. Are cosmologists aware of this problem? Yes. Some try to avoid it by claiming that the universe actually consists of balanced amounts of positive and negative energy, which all add up to zero. In other words, even though the universe looks like something, it's actually just nothing. Therefore, they say, On a net basis, the Big Bang didn't really create anything, so there's no problem with physics being violated. This claim is false, though. This idea doesn't work. So the Big Bang continues to violate physics in the most fundamental way and on the largest possible scale. Now let's move on and discuss not one, not two, but three major predictions made by the Big Bang model that have failed. As the original Big Bang model was developed, cosmologists realized that there are some important ways in which the model doesn't match the universe. For one thing, the Big Bang should have produced massive numbers of magnetic monopoles, magnetic particles with only one pole. These particles should fill the universe, but not a single magnetic monopole has ever been found. Another problem, called the horizon problem, was discovered when astronomers started getting better data on the cosmic microwave background. To make a long story short, if the Big Bang had happened, then the CMB should contain large-scale temperature irregularities. But these irregularities aren't there. As I said earlier, the temperature differences in the CMB are minuscule. And yet another problem was discovered in the geometry of space. The Big Bang should have produced a universe with either massive positive curvature or massive negative curvature. But astronomers discovered that the universe is flat to a very fine degree of precision. It's not curved either way, which again contradicts the Big Bang model's expectations. If you're wondering what curvature of the universe means, it's a geometrical measurement of the cosmos that astronomers use. The important thing is that the Big Bang model said that the universe would have massive curvature in one direction or another, but it doesn't. It apparently has zero curvature. Each of these problems contradicted the Big Bang's predictions, and each one presented a fatal challenge to the model. So cosmologists were relieved when in 1980, a cosmologist named Alan Guth proposed a radical new idea that is now called inflation. Inflation says that right after the Big Bang occurred, the entire universe grew explosively for a very short time. Actually, grew isn't really the right word. We're talking about the entire universe exploding in size at multiple times the speed of light. As one physicist explained, at this rate of inflation, a region of space the size of a pea would be stretched larger than the observable universe in a time interval so short that the blink of an eye would overestimate it by a factor larger than 1,000,000 billion billion billion. And it turns out that for various reasons, inflation supposedly resolves all three of the problems I just mentioned. And so, inflation is a vital part of the Big Bang model today. It's the only explanation cosmologists have found for these three fatal problems. But it turns out that inflation has failed and doesn't actually rescue the Big Bang from its problems after all. First of all, it's important to note that even if inflation were true, it still wouldn't solve the Big Bang's other problems outside of these three. For example, it doesn't help solve the problem of everything coming from nothing. As Guth himself has admitted, inflation itself takes a very small universe and produces from it a very big universe. But inflation by itself does not explain where that very small universe came from. Second, cosmologists have no explanation for how inflation could have occurred. There's nothing in physics that can explain this process. Supposedly, inflation was driven by a particle called an inflaton. But has anybody ever seen an inflaton? No. Is there any room within particle physics for an inflaton? No. Is there any justification for believing in the inflaton, or inflation overall, other than the fact that the Big Bang model needs it? No. As one physicist admitted, inflation's theoretical underpinnings may be rather tentative. The inflaton, after all, is a hypothetical field whose existence has yet to be demonstrated. And as an article in Astronomy magazine explained, what drove inflation? Nobody knows. Physicists have suggested different models to describe the inflating universe, but all the solutions are mathematical conveniences with no particular physical basis. All the theories of inflation amount to proof that we don't have one good theory yet, says this astrophysicist. So inflation is the name given for a hypothetical process that's never been observed, based on a hypothetical particle that's never been observed, and that has no basis in physics. But according to secular cosmologists, even though inflation has no basis in physics, it must have happened, because otherwise the Big Bang model would be falsified, and we know the Big Bang model is true. See the reasoning here? Secular cosmologists often say that we know inflation happened, because otherwise the Big Bang model would have the monopole problem, the horizon problem, the flatness problem, and so on. But that's a logical fallacy. Evidence against the Big Bang model is not evidence for inflation. Overall, Inflation is a belief that's driven not by good physics or even by good logic, but merely by a desire for the Big Bang to be true. In other words, to explain away some of the fatal problems in their model, secular cosmologists are invoking something that's unknown to science and that has no apparent basis within science. That's not a scientific explanation. That's an appeal to miracles. Now, as a Christian, I accept that the creation of the universe was a miracle, done by an omnipotent, omniscient creator. But here we see that secular cosmologists also believe in miracles, even though they claim to deny them. So far, we've seen that the Big Bang has severe problems, including, how can a universe come from nothing? How can nothing turn itself into everything? How can inflation account for anything? And so on. But along with theoretical questions like these, the Big Bang also has problems with physical evidence, things that we see in the universe. Let's talk about some of those now. First of all, there are indications that there might be some stuff in the universe that we can't see. For example, many galaxy clusters don't appear to have enough mass to hold themselves together gravitationally. When this was first discovered, astronomers called it the missing mass problem. Another example is seen within individual galaxies, where stars move around as they orbit the galaxy's center of mass. However, in many galaxies, the outer stars are moving too quickly for the galaxies to hold themselves together over long timescales. Again, it was proposed that there's a lot of missing mass somewhere to hold them together. Most astronomers today believe that these observations indicate that there is actually mass there to hold these structures together. They believe that this mass isn't really missing because it's there. It's just that we can't see it. But if these observations were actually caused by mass that we can't see, how much of it would there be? A lot. Almost 6 times as much as the visible mass. For every galaxy you see, there would be almost 6 galaxies worth of stuff that you don't see. In other words, only 15% of all the physical stuff in the universe would be visible to us. The other 85% would be invisible. This invisible mass has been named cold dark matter. Matter because it's physical stuff, cold because it's moving at slow speeds, and dark because it's invisible. Now, when I say it's invisible, I'm not saying we can't detect it because it's too small or too dark to see. No, it's invisible in its very essence. It emits no visible light, no X-rays, no radio waves, nothing. Nor does it absorb any light or reflect any light. In fact, it doesn't interact with light at all. That's why it's invisible, because light and all other forms of radiation would pass completely through it. This is only one possible explanation, though. There are several other explanations, some of which don't even require there to be any missing mass at all. They account for the observations in other ways. But most secular astronomers reject all these other possibilities. Why? Because they don't fit the Big Bang model. So, because most secular astronomers believe in the Big Bang, they must believe that the missing mass is made up of cold dark matter, an exotic new form of matter that's not made up of atoms, but some other particles that are invisible. Matter like this would be outside of known physics. That's why you'll see astronomers frequently make comments like this one. What exactly is it? What is it made from? Well, the simple answer is, we don't know. No known particle fits the description. And as a Princeton cosmologist has commented, it's an embarrassment that the dominant forms of matter in the universe are hypothetical. Even though there are no good theoretical candidates for dark matter particles, many physicists have been looking for them anyway. So far, the searches have been unsuccessful. But let's say that someday, researchers actually found a new particle that meets this description. Would that support the Big Bang model and discredit the creation model? No, it wouldn't. If new forms of matter were found, the current Big Bang model would need to be modified to account for them. If cold dark matter were discovered, and if it turned out to be the explanation for the missing mass, this wouldn't be a triumph for the Big Bang model. Instead, it would require yet another modification of the Big Bang model. Yet another bandage slapped onto a theory that has already accumulated a pile of them. Remember, the Big Bang was supposed to have created all the matter in the universe, and this would include dark matter, if it exists. However, the current Big Bang model was set up to explain only normal matter. It has no explanation for this mysterious stuff that's supposed to make up 85% of the mass of the universe. As one astrophysicist explained, really, we have no idea what's causing it. We so don't know what's causing it that we shouldn't even call it dark matter, because that implies we have some understanding that it's matter. We don't know what it is. I could call it Fred. 85% of all the gravity in the universe comes from something about which we know nothing. Let me rephrase that last sentence. 85% of all the gravity in the universe comes from something about which the Big Bang model knows nothing. Along with dark matter, there's more in the universe about which the Big Bang model knows nothing. A lot more, in fact. In the late 1990s, astronomers were studying some faraway supernovae. Supernovae are enormous explosions in space that occur under certain circumstances. For example, if a white dwarf star pulls material off of a companion star, it can only do this until a critical threshold is reached. At that point, the white dwarf quickly explodes in a massive, violent catastrophe. Anyway, astronomers were studying these supernovae, and they discovered something unexpected. The astronomers calculated the distance of the supernovae by measuring the brightness of the explosions. Then they calculated the distance that the Big Bang model predicted based on the redshifts, and the distances were slightly different. What does this mean? Well, according to the Big Bang model, this means that not only is the universe expanding, but the expansion rate is also accelerating. In other words, it's not only getting bigger, it's getting bigger faster and faster. According to the Big Bang model, all of the space in the universe must be filled with some kind of anti-gravity energy, driving the universe into expanding faster and faster, even though mutual gravitation among all the galaxies would otherwise prevent this. The Big Bang model requires a tremendous amount of this energy, filling the entire universe, and growing as the universe itself expands. So what is this mysterious anti-gravity energy that the Big Bang model requires? It's become known as dark energy, not because it's something that looks dark, but because it's similar in some ways to the concept of dark matter. Just like dark matter, it's outside of known physics. Nobody has ever seen any, and nobody has any idea of what it could possibly be. Earlier we saw that secular cosmologists believe that 85% of the physical stuff in the universe is invisible cold dark matter. But this invisible dark energy would be about twice as abundant as all the physical mass is, about 68% of the total mass energy of the universe. As an article in Astronomy magazine explained, to get enough oomph, that's a technical cosmological term there, to drive the present acceleration of the universe, dark energy must make up about 68% of the total density of the universe. The biggest problem with this idea is that no one has any idea what dark energy is. So far, all we've been able to do is name it. So what exactly is dark energy? The obvious answer is, again, we don't know. Actually, the situation is even worse. We really don't know. Although cosmologists have adopted a cute name, dark energy, for whatever is driving this apparently anti-gravitational behavior on the part of the universe, nobody claims to understand why it is happening, or its implications for the future of the universe and of the life within it, despite thousands of learned papers, scores of conferences, and millions of dollars worth of telescope time. The nature of dark energy is now perhaps the most profound mystery in cosmology and astrophysics, and it may remain forever so. Let me repeat, we don't actually observe any dark energy in the cosmos. The only things we observe here are the brightness of the supernova explosions as seen from Earth, and the redshifts that we measure in the light. So dark energy is not something that's observed. It's just an interpretation of the observations that's required by the Big Bang model. So once again, the Big Bang model requires something that is completely outside of known physics. In this case, anti-gravity energy. And once again, the Big Bang model has no explanation for what it is or how it formed. So let's review. There's a lot of stuff in the universe that we can see: planets, stars, galaxies. However, there might be some mass out there that we can't see. Most astronomers believe that this is made up of mysterious dark matter, some new form of invisible non-atomic matter that's almost 6 times as abundant as the matter we can see. And then there were some supernova observations. If you interpret them according to the Big Bang model, they would indicate that there's this mysterious anti-gravity stuff called dark energy that's more than twice as abundant as the matter is. In other words, everything we can see in the universe, its planets, stars, and galaxies, only make up between 4 to 5% of the universe. Dark matter, which the Big Bang model requires but doesn't explain, makes up about 27%. And dark energy, which again the Big Bang model requires but doesn't explain, makes up about 68%. Now the Big Bang was supposed to explain where the universe came from. In other words, it was supposed to explain the origin of everything. But here we see that the model doesn't actually explain everything. Even if it were good science, which it's not, it would still explain only 5% of everything. So if your theory of everything only attempts to explain 4 or 5% of everything, do you really have a theory of everything? I think the answer is clear. Even many secular scientists are unhappy with the situation. As one astrophysicist has complained, it really is strange, and to our perhaps uneducated eyes, arbitrary, ugly, or accidental. To live in a universe where only 4% of matter is ordinary matter, I find awkward at best, implausible at the least, but there it is. If I didn't have all these facts in front of me, and you came up with a universe like that, I'd either ask what you've been smoking, or tell you to stop telling fairy tales. Despite all of the problems with the Big Bang model, most secular cosmologists still insist that there's strong evidence for it, so it must be true. Let's talk about that for just a moment. As we saw earlier, there are 3 primary lines of evidence that are claimed to support the Big Bang: redshifts of distant objects, the abundance of light elements, and the CMB, or cosmic microwave background. Redshifts are indeed consistent with the Big Bang model, but they're also consistent with other cosmological models too, so they don't require the Big Bang to be true. As for the close match between the Big Bang model and the observed abundance of light elements, this too isn't as impressive as cosmologists claim. First of all, this wasn't a prediction made ahead of time. The abundances were already known when the Big Bang model was being developed, so the model was just tweaked to match them. Second, it also turns out that even after this tweaking, there are still some discrepancies between the predictions and the actual observations. And third, just like redshifts, the abundances are consistent with other cosmologies besides the Big Bang anyway, so light element abundances aren't very persuasive evidence for the Big Bang model after all. But what about the CMB, the cosmic microwave background radiation? What about this discovery that supposedly proves the Big Bang model is true? As we saw earlier, the CMB was the crowning glory for the Big Bang model. The CMB's existence is the one major prediction that the model seemed to make successfully. But unfortunately for secular cosmologists, the more we've learned about the CMB, the more trouble it's caused for their model. As this video is being made, the best measurements of the CMB have come from the Planck spacecraft. Planck has verified what previous studies had already found, that there's a large-scale pattern of temperature differences in the CMB that the Big Bang model can't accommodate. We've already discussed how the temperature differences between any 2 points in the sky is very small, which causes enormous trouble for the Big Bang model. But it also turns out that these small temperature differences are arranged in an overall pattern that the Big Bang model can't explain. This pattern is called the axis of evil, which tells you how secular astronomers feel about it. They don't like it because it discredits their ideas about the Big Bang model. As one author commented, the apparent alignment in the cosmic microwave background in one particular direction through space is called evil because it undermines our ideas about the standard cosmological model. Along with the axis of evil, Planck also showed a large cold spot in the CMB. Again, this doesn't match the Big Bang model. And as if this weren't enough, cosmologists have recently realized that the Planck data have discredited a lot of their ideas about inflation. As these astrophysicists noted, thanks to the Planck mission, the Big Bang's inflationary paradigm is now in trouble. The models most favored by their data, combined with earlier results, suffer from exacerbated forms of initial conditions and multiverse problems, and they create a new difficulty that we call the inflationary unlikeliness problem. That is, the favored inflaton potentials are exponentially unlikely, according to the logic of the inflationary paradigm itself. The unlikeliness problem arises even if we assume ideal initial conditions for beginning inflation, ignore the lack of predictive power stemming from eternal inflation and the multiverse, and make no comparison with alternatives. Thus, the 3 problems are all independent, all emerge as a result of the data, and all point to the inflationary paradigm encountering troubles that it did not have before. Remember, inflation is necessary to solve 3 problems that would otherwise be fatal for the idea of a Big Bang. We already discussed that inflation isn't a valid solution anyway. But even if you set that aside, new observations of the CMB make inflation look extremely unlikely, which means it's extremely likely that the Big Bang model has those original fatal problems again. By this point in the video, you might be wondering about something. You've probably been told that secular cosmologists have lots of evidence for the Big Bang, and that all competent scientists believe the model. But if, as we've seen in this video, the Big Bang model really fails so badly, then why do all the scientists believe in it? Well, the answer is that all the scientists don't believe in it. There are many scientists who are Bible-believing Christians who obviously don't accept the Big Bang, nor should they. But there are also many secular scientists who reject the Big Bang model. To be clear, these scientists are in the minority. Among secular astronomers, the Big Bang model is still the majority view. But that doesn't mean the model is correct. Science is not politics, and truth is not determined by which idea gets the most votes. Meanwhile, even many non-Christian astrophysicists understand that the Big Bang model has failed. As one wrote, "To explain some surprising observations, theoreticians have had to create heroic and yet insubstantial notions, such as dark matter and dark energy, which supposedly overwhelm, by 100 to 1, the stuff of the universe we can directly detect. Outsiders are bound to ask whether they should be more impressed by the new observations or more dismayed by the theoretical genies that have been conjured up to account for them. Modern cosmology has, at best, very flimsy observational support." In its original form, an expanding Einstein model had an attractive economic elegance. Alas, it has since run into serious difficulties, which have been cured only by sticking on some ugly bandages. Inflation to cover horizon and flatness problems, overwhelming amounts of dark matter to provide internal structure, and dark energy, whatever that may be, to explain the seemingly recent acceleration. A skeptic is entitled to feel that a negative significance, after so much time, effort, and trimming, is nothing more than one would expect of a folk tale, constantly re-edited to fit inconvenient new observations. And as other authors have said, the whole thing has the feeling of something held together with a band-aid. If it hadn't been for the addition of the idea of inflation, the whole concept wouldn't work. And the trouble with inflation is that although it's something that would make what's observable possible, no one can come up with a decent explanation as to why it should have happened. "Look at the facts," says Ricardo Scarpa of the European Southern Observatory in Santiago, Chile. "The basic Big Bang model fails to predict what we observe in the universe in 3 major ways. The temperature of today's universe, the expansion of the cosmos, and even the presence of galaxies have all had cosmologists scrambling for fixes. Every time the basic Big Bang model has failed to predict what we see, the solution has been to bolt on something new: inflation, dark matter, and dark energy," Scarpa says. Today's standard model of cosmology has become an ugly mishmash comprising the basic Big Bang theory, inflation, and a generous helping of dark matter and dark energy. Big Bang theory relies on a growing number of hypothetical entities, things that we have never observed. Inflation, dark matter, and dark energy are the most prominent. Without them, there would be fatal contradictions between the observations made by astronomers and the predictions of the Big Bang theory. In no other field of physics would this continual recourse to new hypothetical objects be accepted as a way of bridging the gap between theory and observation. But the Big Bang theory can't survive without these fudge factors. We see then that even many secular scientists recognize that the Big Bang model is a folktale, an ugly mishmash of discredited ideas and bandages meant to rescue the theory from the facts. And as we'll see next, that ugly mishmash is about to get far uglier. The Big Bang model is supposed to explain how the universe got here without any sort of intelligent creator being involved. Supposedly, the universe just happened. If that were true, then you'd expect the universe to look like the outcome of random natural processes. You wouldn't expect the universe to look extremely fine-tuned, but that's exactly what we see. Now, entire books have been written on how well-designed and fine-tuned the Earth is to support life. Some of these are even from secular authors. In the previous video in this series, we also talked about how well-designed the sun is too, and how none of this should surprise us, because the Bible says that the Lord created this world for us to live here. Secular astronomers, though, have no explanation for this. All they can say is that if the Earth weren't a suitable home, we wouldn't be here to observe it. Obviously, this isn't a very satisfactory explanation. It turns out, though, that this problem is bigger than the Earth and Sun. Far bigger, in fact. The entire universe appears to be fine-tuned for us to be here. This extends beyond objects like planets and stars, into the very fundamentals of physics itself. Many of the laws, forces, and constants of physics have very fine-tuned values. If you change them even slightly, the universe would be vastly different, and we wouldn't be here to observe it. As famed cosmologist and atheist Stephen Hawking has written, a change of as little as 0.5% in the strength of the strong nuclear force, or 4% in the electric force, would destroy either nearly all carbon or all oxygen in every star, and hence the possibility of life as we know it. Change those rules of our universe just a bit, and the conditions for our existence disappear. Most of the fundamental constants in our theories appear fine-tuned, in the sense that if they were altered by only modest amounts, the universe would be qualitatively different, and in many cases, unsuitable for the development of life. For example, if protons were 0.2% heavier, they would decay into neutrons, destabilizing atoms. Our universe and its laws appear to have a design that both is tailor-made to support us, and, if we are to exist, leaves little room for alteration. That is not easily explained, and raises the natural question of why it is that way. Many other scientists agree with this. There is now broad agreement among physicists and cosmologists that the universe is in several respects fine-tuned for life. It is fine-tuned for the essential building blocks and environments that life requires. This fine-tuning extends even to the features of individual atoms. As astrophysicist Sir Fred Hoyle, who is not sympathetic to creationism, wrote, "Some supercalculating intellect must have designed the properties of the carbon atom. Otherwise, the chance of my finding such an atom through the blind forces of nature would be utterly minuscule." A common-sense interpretation of the facts suggests that a super-intellect has monkeyed with physics, as well as with chemistry and biology, and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question. Now, to be clear, many of these fine-tuning arguments are based on the Big Bang model. Obviously, I don't accept the Big Bang. But it's fascinating that the Lord created the universe in such a way that even a theory designed to deny His creation still makes the universe look designed and extremely fine-tuned. As one physicist wrote, "Life appears to depend upon delicate coincidences that we haven't been able to explain." Another said, "Our own universe is an extraordinary place that appears to be fantastically well designed for our own existence. This specialness is not something that we can attribute to lucky accidents, which is far too unlikely. The apparent coincidences cry out for an explanation." Years ago, some scientists attempted to calculate how finely tuned the Big Bang had to be if such an event had actually produced our universe. The answer they got was that the Big Bang explosion had to be precisely tuned to within 1 part in 10 to the 60th power. That's a 1 with 60 zeros after it. Here's an illustration of this. As you probably know, the planets, stars, and galaxies of our universe are made of atoms. If a Big Bang event actually created our universe, then it created about 10 to the 80th power atoms. If this creation event had to be finely tuned to within 10 to the 60th power, then the number of atoms could only have varied by 10 to the 20th power. That's about the same number of atoms contained in a single grain of sand. The calculation showed that the Big Bang model couldn't tolerate any variation more than this. If a Big Bang had actually happened, but it had created just the tiniest additional bit of matter, if it had created just 1 extra grain of sand than what's currently in our universe, then we wouldn't be here, because our universe would have collapsed into a black hole long ago. On the other hand, if a Big Bang had created a universe with just the tiniest bit less matter, if it had created just 1 grain of sand less, then the universe would be completely empty today, because space would have expanded too quickly and galaxies could never have formed. Either way, if the alleged Big Bang had produced 1 grain of sand more or 1 grain of sand less, we wouldn't be here. We couldn't be here. In other words, the idea that a Big Bang created our entire universe, the idea that a random event could be so precisely finely tuned down to a single grain of sand, is ridiculous. But believe it or not, when cosmologists added dark energy to the Big Bang model a few years later, the fine-tuning got even worse. Far worse, in fact. It turns out that dark energy also has to be finely tuned, to 1 part in 10 to the 123rd power. Now we've gone from ridiculous to silly. As cosmologists have admitted, our universe appears surprisingly fine-tuned for life. in the sense that if you tweaked many of our constants of nature by just a tiny amount, life as we know it would be impossible. Some of the fine-tuning appears extreme enough to be quite embarrassing. For example, we need to tune the dark energy to about 123 decimal places to make habitable galaxies. Now we're talking about fine-tuning that's far less than a grain of sand. If there are 10 to the 80th power atoms in the universe, and the Big Bang's dark energy has to be finely tuned to 10 to the 123rd power, then the Big Bang's precision must be a tiny fraction of the average atom in the universe, just 10 to the minus 43rd power. In other words, the precision required for the Big Bang is now far less than a grain of sand. It's far less than one atom within a grain of sand, or 1/10 of an atom, or 1/100th of an atom. No, the required precision is this ridiculously tiny fraction of the mass energy contained within a single atom. That's how precisely fine-tuned the alleged Big Bang had to be. For scientists who want to deny a creator, finely tuned dark energy discredits a random Big Bang so thoroughly that one described it as a cataclysm for physicists. We've seen that even according to the Big Bang model, the universe looks exceptionally fine-tuned. How do secular cosmologists explain this? Actually, they don't have one explanation. They think they have an infinite number of explanations, thanks to something called the multiverse. The multiverse means multiple universes, the idea that our universe is not the only universe that exists. Now this probably sounds strange because how can there be more than one universe? After all, the word universe means all that there is. Well, cosmologists have redefined the word. The word universe now refers to that part of reality that we could ever perceive. So other universes refers to regions in physical reality that are beyond our observation, not just now, but ever, even with the best conceivable telescopes and so on. The collection of all these universes is called the multiverse. Today, countless cosmological articles and papers have been written, and continue to be written, about the multiverse. Although the early versions of the Big Bang model didn't include this concept, today's Big Bang model does say that there are infinitely many universes out there beyond our perception. It might sound weird, but this is mainstream today within the cosmology community. This is a key point, because in just a moment, we're going to see that the multiverse idea creates tremendous problems for the Big Bang model's claim to be scientific. But sometimes when you point this out to people, they'll claim that the multiverse isn't part of the Big Bang model. So let me emphasize again. It's true that the original Big Bang model didn't include a multiverse, but that's changed. Today's Big Bang model does produce a multiverse, and for more than one reason. For example, most cosmologists today believe that the cosmos has zero curvature and is infinite. This leads directly to a multiverse, because there would be an infinite number of universes we'd never be able to see. As we discussed earlier, most cosmologists also believe in inflation. It's an important part of the Big Bang model today. The original idea of inflation said that the universe inflated for a short time and then stopped, which supposedly formed our early universe. But cosmologists have realized that once inflation begins, it goes on eternally, spawning an infinite number of universes as it goes. This goes on forever. Inflation will produce an infinite number of universes because it can never stop. As cosmologist Alan Guth pointed out, eternal inflation is the almost unavoidable consequence of our best understanding of the fundamental laws of physics. And as another cosmologist has said, garden-variety inflationary models yield a gargantuan number of bubble universes carved into an eternally expanding spatial expanse. The existence of an inflationary multiverse would be an inevitable consequence. The multiverse is now well established within cosmology, and even in popular science books. In fact, it's big business now. If you need some extra money, just write a book about all the universes out there that nobody can ever see. After all, who can prove you wrong? Anyway, most secular cosmologists are actually happy that the Big Bang predicts a multiverse, because they think it allows them to escape the fine-tuning problem. After all, if the multiverse contains an infinite number of universes, then it doesn't matter that our universe is extremely fine-tuned and appears to be well-designed and is outlandishly unlikely to have formed in a random Big Bang, because in an infinite number of universes, even the most unlikely universe will exist somewhere. And according to most secular cosmologists, we just happen to live in such an unlikely universe. As two cosmologists commented, this picture of the universe, or multiverse as it is called, explains the long-standing mystery of why the constants of nature appear to be fine-tuned for the emergence of life. The reason is that intelligent observers exist only in those rare bubbles in which, by pure chance, the constants happen to be just right for life to evolve. The rest of the multiverse remains barren, but no one is there to complain about that. Call it a fluke, a mystery, a miracle, or call it the biggest problem in physics. Short of invoking a benevolent creator, many physicists see only one possible explanation. Our universe may be but one of perhaps infinitely many universes in an inconceivably vast multiverse. Most of those universes are barren, but some, like ours, have conditions suitable for life. The idea is controversial. Critics say it doesn't even qualify as a scientific theory, because the existence of other universes cannot be proved or disproved. Advocates argue that, like it or not, the multiverse may well be the only viable, non-religious explanation for what is often called the fine-tuning problem, the baffling observation that the laws of the universe seem custom-tailored to favor the emergence of life. But even though this idea is popular among secular scientists, is it actually good science? Let's think about this. First, look at this sentence in the article. Critics say it doesn't even qualify as a scientific theory, because the existence of other universes cannot be proved or disproved. That's a correct statement. By definition, all the other universes outside of our own would be unobservable. Therefore, there's no experiment or observation you could perform that would either confirm or disprove this idea. In other words, the multiverse is not a theory that's open to scientific investigation. It's just an item of faith. Plus, think about the implications of the multiverse. If we live in an infinite ocean of universes, then there's an infinite number of universes that are almost exactly like the one that you're in now. As one cosmologist explained, in the far reaches of an infinite cosmos, there's a galaxy that looks just like the Milky Way, with a solar system that's the spitting image of ours, with a planet that's a dead ringer for Earth, with a house that's indistinguishable from yours, inhabited by someone who looks just like you, who is right now reading this very book or watching this very video. And there's not just one such copy. In an infinite universe, there are infinitely many. If the cosmos is infinitely large, it is home to infinitely many parallel worlds. Another wrote, "Is there another copy of you reading this article? A person living on a planet called Earth, with misty mountains, fertile fields, and sprawling cities. You probably find this idea strange and implausible. Yet it looks like we will just have to live with it, since the simplest and most popular cosmological model today predicts that this person actually exists in a distant galaxy. Your alter ego is simply a prediction of the so-called concordance model of cosmology, which is used as the basis for most calculations and simulations presented at cosmology conferences. If space is infinite, and the distribution of matter is sufficiently uniform, then even the most unlikely events must take place somewhere. In particular, there are infinitely many other inhabited planets, including not just one but infinitely many, with people with the same appearance, name, and memories as you. Indeed, there are infinitely many other regions the size of our observable universe where every possible cosmic history is played out. If we live in an infinite multiverse, then there are an infinite number of universes, and everything that's possible has occurred somewhere. There's a universe where you are watching this video, and everything else is exactly the same as in this universe, except that you had something different for breakfast this morning. There's an infinite number of universes where the South won the American Civil War. There's an infinite number of universes where there never was a civil war because the original 13 colonies lost the revolution against King George III, and so on. In a multiverse, even the most unlikely events must take place somewhere. Remember this phrase, because this idea has very important consequences, as we'll see later. And also remember that this is the mainstream view within cosmology now. As an article in New Scientist said, our most successful theories lead to the inescapable conclusion that our universe is just a speck in a vast sea of universes. The multiverse is not some kind of optional thing, like can you supersize or not, says this theoretical physicist at the University of California in Berkeley. Our own cosmological history, he says, tells us that it's there and we need to deal with it. So remember, regardless of how weird the multiverse may sound, secular cosmologists demand that it's true, and you just need to deal with it. But what they aren't telling you is that the multiverse is devastating to their claims that they're actually doing science at all. We'll talk more about this in just a moment. And that brings us to the end of this section. In the first part of this video, we saw why the Big Bang model is claimed to be good science. In this section, we saw that it's not such good science after all. Everything cannot have come from nothing. The claim that it did violates the most fundamental principles of physics. Also, some cosmologists who claim that everything came from nothing don't really believe that there was nothing before the Big Bang. They actually believe that there was something rather than nothing. But they have no explanation for where this something came from, or how it could sit there for an eternity, or why it would suddenly decide to turn into a universe for no reason. The Big Bang has several fatal problems, which secular cosmologists try to solve by invoking a short period of inflation early in the Big Bang. But the particle that supposedly caused this, called the inflaton, is completely hypothetical. It's completely unknown to physics. So in order to rescue the Big Bang from its problems, cosmologists are invoking things that are outside of science. Cosmologists also have no way to stop inflation once it starts. Once begun, inflation is an eternal process and produces an infinite number of universes. The Big Bang model requires the universe to be filled with cold dark matter, but the model has no explanation for what cold dark matter might be, or how it came to exist. Other observations indicate that if the Big Bang model is true, then the universe must be filled with some mysterious anti-gravity stuff that secular cosmologists call dark energy. But again, the Big Bang has no explanation for what dark energy might be, or how it came to exist. Cosmologists claim that the Big Bang model explains everything. But even if it were a good model, which it isn't, it would still only explain 5% of everything, which means 95% of the mass energy of the universe is unexplained by the model. The cosmic microwave background is claimed to be good evidence for the Big Bang, but recent measurements of it are causing large problems for the model instead. The Big Bang model requires an extreme amount of fine-tuning, not only in the Big Bang itself, but also in many areas of physics. This is deeply embarrassing to secular scientists who want to deny a creator. The Big Bang model also predicts a multiverse, containing an infinite number of universes, which among other things means there are infinite other copies of you spread throughout the cosmos. This supposedly avoids the fine-tuning problem, but all these other universes would be beyond our perception, so there's no way to investigate this idea to see if it's true. This means that this idea is outside of science. Well, that's quite a list, isn't it? But the problems with the Big Bang model actually go far deeper even than these listed here. We've already seen that the Big Bang model isn't good science. But it also turns out that when you really dig into it, it's not even bad science. The Big Bang model is actually anti-science, because when you take the model to its logical conclusions, it makes science itself impossible. Let's talk about that now. For this section, I said I'd give you a reason why the Big Bang model is anti-scientific. I'm actually not going to give you one reason. I'm going to give you 5 reasons why the Big Bang is explicitly contrary to the most fundamental principles of science. Here they are. The model violates the laws of physics. The model denies the laws of physics. The model is self-contradictory. The model has absurd implications. The model refutes itself. Let's talk about these in order. Reason number 1. The Big Bang model violates the laws of physics. We've already seen that the Big Bang model violates some of the most important principles of physics, like the conservation of mass and energy. Any model which claims to be scientific, while violating the most fundamental laws in science, isn't actually scientific. That's pretty straightforward. Reason number 2 is a bit more subtle. The Big Bang contradicts the laws of physics in an even deeper way than just violating them. Here's a question. What's the most basic, the most fundamental thing you need in order to do physics? You might think the answer is laboratory equipment, or maybe the scientific method. Or something even more basic would be our senses, so we can make observations of the world around us. But there's something more basic even than all of these. The most basic thing you need in order to do physics is a universe to which physics can be applied. And the Big Bang model can't supply this. Earlier we discussed how the Big Bang model says that time didn't exist before the Big Bang occurred. The Big Bang is supposedly the very first event in history. That's why cosmologists frequently make comments like this one. If space spontaneously popped into existence, so did time. Namely, time and space are both classical concepts that may have a limited domain of validity, And so, the question what was before the Big Bang may simply be a bad question, because there was no before. Time didn't exist. Think about what this means. It means that the Big Bang had no cause, because a cause has to come before its effect. And before the Big Bang, there was no time in which a cause could have occurred. As one astronomer explained, maybe there was no ultimate cause for the universe. It just happened. And another cosmologist famously said, the universe is simply one of those things that happens from time to time. Well, if the universe just happened, if there was no reason for it to create itself, if the universe's self-creation was a random event, then the universe was founded in randomness. It would inherently be a random thing. But science requires that the universe operate consistently and non-randomly. Science requires that the universe operate according to strict laws of physics, so that we can perform experiments to discover those laws and understand how the universe works. Science requires the universe to operate according to consistent patterns of behavior, so we can test and explore and eventually discover those patterns. But according to secular cosmologists, the universe was founded in randomness. So, do these cosmologists have the right then to expect the universe to operate according to strict laws of physics afterwards? No, they don't. It would seem instead that a universe which began in randomness would stay random. Now, scientists who approach science biblically don't have this problem. The Bible says that our Creator is a God of order. He upholds the universe by the word of His power. Unless He intervenes in the form of a miracle, the creation works according to consistent laws. Not only that, He has promised that the creation will continue to operate according to regular and predictable patterns. So scientists who believe in the Bible can trust that there are laws of physics, and that science is therefore possible. But secular cosmologists deny that there is a creator who made an orderly universe. They insist that everything came from randomness, for no reason whatsoever. But if everything is random, which is what the Big Bang model implies, then science becomes impossible. Therefore, secular cosmologists have no reason to expect science to work. Am I saying that someone who isn't a Christian can't do science? No, I'm not. In fact, there are many good scientists who are secular and don't believe in a creator, but they aren't doing science while acting consistently with their secular beliefs, because that would be impossible. Instead, they're basically borrowing from the Christian worldview and assuming that the universe is orderly despite the implications of the Big Bang model. As one physicist has pointed out, people take it for granted that the physical world is both ordered and intelligible. The underlying order in nature, the laws of physics, are simply accepted as given, as brute facts. Nobody asks where they come from. At least they don't in polite company. However, even the most atheistic scientist accepts as an act of faith the existence of a law-like order in nature that is at least in part comprehensible to us. So science can proceed only if the scientist adopts an essentially theological worldview. Reason 3. The Big Bang model is self-contradictory. Think about the multiverse idea for a moment. Remember, it's part of the Big Bang model, and it's there, and we need to deal with it. But even secular cosmologists admit that the subject of parallel universes is highly speculative. No experiment or observation has established that any version of the idea is realized in nature. The multiverse says there's an infinite number of universes outside of our own. By definition, all the other universes can't be perceived. They're unobservable. What word do we use to describe things that are outside of our observable universe? If they're outside of the universe we can see, then they're outside of the natural world, which means they're supernatural. That's what the word means, right? Outside of nature, beyond nature. But earlier we saw that the Bible was rejected as a possible explanation for the universe because it offers a supernatural explanation. Here we see that the Big Bang model is doing the same thing. In fact, do you remember that definition of science we saw at the beginning of this video? Modern science does not deal with supernatural explanations because they are not scientifically testable. In other words, there's no way to gather evidence that would help us determine whether or not the explanations are accurate. Well, that description perfectly matches the multiverse. By definition, all the other universes can't be detected. And since the Big Bang model requires a multiverse, this means that the Big Bang model ultimately isn't scientific. Even some secular thinkers agree with this. These multiverse theories all share the same fundamental defect. They can be neither confirmed nor falsified. Hence, they don't deserve to be called scientific. Multiverse theories aren't theories. They're science fictions, theologies, works of the imagination unconstrained by evidence. Another said, "My own moral concerns about the multiverse have more to do with worry that pseudoscience is being heavily promoted to the public. If a wrong idea is promoted for enough years, it gets into the textbooks and becomes part of the conventional wisdom about how the world works. This process is now well underway with multiverse pseudoscience." After the initial period of creation, the biblical account of origins is consistent with both the laws of science and the practice of science, but the Big Bang model is not. Instead, the Big Bang model denies supernatural explanations, while at the same time, it requires supernatural explanations. Its claims to be science are self-contradictory. Reason 4. The Big Bang model has absurd implications. In Matthew 7:20, Jesus said, "By their fruits ye shall know them." If the Big Bang were a good model, then its fruits would be good science. But if it's not a good model, then its fruits will be wrong, or perhaps even absurd. So let's examine the fruits of the Big Bang theory and of secular cosmology overall, and for each item we'll ask, is this actually good science, or is it just science fiction? We'll start with the fine-tuning of the universe. We saw earlier that cosmologists are wrestling with this and trying to deny the creator that this fine-tuning implies. Some have said that the universe is fine-tuned because we cause it to be that way, just by looking at it. As an article in New Scientist explained, maybe we should approach cosmic fine-tuning not as a problem, but as a clue. Perhaps it is evidence that we somehow endow the universe with certain features by the mere act of observation. It's an idea that Stephen Hawking has been thinking about too. Hawking advocates what he calls top-down cosmology, in which observers are creating the universe and its entire history right now. If we in some sense create the universe, it's not surprising that the universe is well suited to us. In other words, the universe doesn't really exist on its own. We create it just by looking at it, so of course it would be fine-tuned for us, because we're the ones creating it. That's an amazing story. But is it science, or just science fiction? Meanwhile, some other cosmologists don't like the idea that the universe had a beginning, because even though the Big Bang model isn't biblical, the idea that the cosmos had a beginning still sounds too much like the book of Genesis. So they're trying to get rid of it by saying that our universe doesn't really have only 3 spatial dimensions. It's actually a multidimensional membrane universe that periodically collides with other multidimensional membrane universes, and each collision creates a new Big Bang in a regular cycle that goes on forever. Of course, none of these other membrane universes are observable to us. Is this science, or just science fiction? Other cosmologists are trying to get rid of a beginning by getting rid of time itself. For example, one wrote, "Our universe may be the offspring of some other universe. Baby universes fluctuate into existence in both directions of time, eventually emptying out and giving birth to babies of their own. On ultra-large scales, such a multiverse would look statistically symmetric with respect to time. Both the past and the future would feature new universes fluctuating into life and proliferating without bound. Each of them would experience an arrow of time, but half would have an arrow that was reversed with respect to that in the others." In other words, there's an infinitely large multiverse, filled with an infinite number of Big Bangs, producing an infinite number of baby universes, none of which we can see. And oh, by the way, in half of those universes, time must flow backwards. Is this science, or science fiction? And while we're talking about the multiverse, we saw earlier that Big Bang believers try to explain away many of their problems with this idea. But a multiverse has implications that are just silly. For example, in a multiverse, there's an infinite number of planets out there with alien life, including an infinite number of planets full of dinosaurs which didn't go extinct like they did on Earth, but continued to evolve instead. Well, what would that imply? One secular scientist, who wasn't writing about the multiverse specifically, still touched on this idea when he warned, "Such life forms could well be advanced versions of dinosaurs. We would be better off not meeting them." Yes, we would be better off not meeting them, because there's nothing worse than meeting up with a dinosaur that has better weapons than you do. And if the multiverse is real, then there are an infinite number of universes out there where humans are fighting advanced dinosaurs, right at this very moment. But is this science?
Look out! There comes another one! I got him!
Or just science fiction? Also, if the multiverse is real, there are an infinite number of planets with intelligent aliens on them. With an infinite number of alien species out there, some cosmologists propose that some of these aliens will have technology that's advanced enough to make new universes, including ours. It is proposed that our universe was created by life of superior intelligence existing in another physical universe. Intelligent beings might possess not only the knowledge to design, but also the technology to build universes. This explains why the constants of physics have their observed finely tuned values. So that's why our universe looks so well designed, because aliens did it. Science? Or science fiction? Other cosmologists point out that in a multiverse, it's possible that aliens didn't actually build our universe, because our universe isn't actually real. These cosmologists say that our universe is only a simulation that aliens are running on their computers. It is a perfectly acceptable supposition that the world as we know it is a vast computer program, run on machines built by an intelligence we know nothing about. If you accept the multiverse idea, it is almost inevitable that there are computer-based universes out there. Somewhere among the universes there would, in all probability, be universes where civilizations had developed far enough to produce a Matrix-style universe. Chances are, we do live in a computer simulation of a universe. So if you think our universe is real, you're wrong. It's actually just a video game being played by some alien somewhere. Do you think this sounds silly? Well, you shouldn't laugh, because this is a serious matter.
This is a serious matter.
Some cosmologists are working on ways to figure out if this is true. And this is important work. This research here was funded by the United States government via the Institute for Nuclear Theory, the National Science Foundation, and the U.S. Department of Energy. These are your tax dollars at work. But is it science? Or science fiction? But wait, it gets even better. If aliens can run computer simulations of universes, then they can also run computer simulations of universes that contain aliens that are running computer simulations of universes. So maybe our universe isn't even an actual computer simulation. Maybe the alien computer that's simulating our universe is itself part of a computer simulation, as this author said. There could even be multiple levels of simulation. The computer our universe runs on could be itself a simulation on another computer. And you could extend this on and on. Maybe the computer that's simulating the simulation is itself a simulation running on a computer that is itself a simulation running on a computer that is itself, well, you get the idea. Do I even need to ask if this is science? Now, not every cosmologist advocates things like our universe being a computer simulation being run by aliens. But the multiverse is completely consistent with this nonsense. And any idea that is consistent with nonsense is itself nonsense. If you accept the multiverse, this is where you wind up, in complete absurdity. Why then do cosmologists, intelligent men and women who claim to be doing good science, insist that such a ridiculous anti-scientific idea is true? Because, as one cosmologist warned, if there is only one universe, you might have to have a fine-tuner. If you don't want God, you'd better have a multiverse. As the Bible says, the fool says in his heart that there is no God. Now don't misunderstand me. I'm not saying that atheistic scientists are stupid. On the contrary, most are very intelligent people. But when you deny the truth, you must believe a lie. When you deny God, you must end up in folly, which is exactly where the atheists are today. By this point, you might think that the Big Bang model couldn't get any sillier than this, but believe it or not, it can. Now it's time to reveal the crowning absurdity of the Big Bang model. Reason 5 might be the ultimate disproof of the Big Bang theory. We've seen that the Big Bang theory is contradicted by the evidence in numerous ways. But just for a moment, let's set all those issues aside. Even though we know that the universe couldn't have come from nothing, and that the Big Bang model violates fundamental physics, and that it requires an extreme amount of fine-tuning, and that it has absurd consequences and so on, let's forget about all that for just a moment. Let's pretend to be secular cosmologists who believe that somehow, despite all the reasons that it couldn't have happened, something still popped into existence anyway. It turns out that even if you believe that, the Big Bang model still can't explain our universe. The Big Bang would still be such an unlikely event that other things, which are also very unlikely, are still much more likely to have happened than the Big Bang, and some of these are absurd. You see, even if a cosmic fluctuation had created our universe, which again it didn't, but we're ignoring this for the moment, the Big Bang model says that mathematically, the early universe would have been in an extremely improbable state, and so, such a fluctuation would also be extremely improbable. It turns out that mathematically, it would be a lot simpler if instead of our entire universe popping into existence, if the cosmic fluctuation only had to make our galaxy. Makes sense, right? In fact, it would be even simpler if the fluctuation didn't have to make our entire galaxy, but only our solar system. And it would be even simpler still if the fluctuation didn't have to make our entire solar system, but only the Earth. And it would be simplest of all if the fluctuation didn't have to make the entire Earth, but it only had to make one small thing, you. Now you might be thinking, wait a minute. Yes, a tiny fluctuation might be mathematically simpler, but if we're thinking like secular cosmologists, we still need the fluctuation to explain everything else too, because the Earth exists, and our solar system exists, and the Milky Way galaxy exists, and so do all the other galaxies. But how do you know everything else exists? You think you perceive all these things with your senses. But what if they're all illusions? What if the universe isn't real? What if it turns out that the fluctuation didn't actually make the entire universe? What if it only made your brain, which popped into existence with false memories and false perceptions of a universe around itself? A brain that's just floating in the void, thinking there's a universe, but there isn't because it's all an illusion. Now you might be thinking that this is one of the silliest ideas you've ever heard, and I would agree with you. But remember, we're thinking like secular cosmologists for a moment. Secular cosmologists have to believe that cosmic fluctuations can make things pop into existence. But according to the mathematics of their models, it's infinitely more likely for a single brain to pop into existence than for the Big Bang to have caused a baby universe to pop into existence. Here's how an article in the New York Times described this problem. It could be the weirdest and most embarrassing prediction in the history of cosmology, if not science. If true, it would mean that you yourself reading this article are more likely to be some momentary fluctuation in a field of matter and energy out in space than a person with a real past born through billions of years of evolution in an orderly star-spangled cosmos. Your memories and the world you think you see around you are illusions. This bizarre picture is the outcome of a recent series of calculations that take some of the bedrock theories and discoveries of modern cosmology to the limit. The basic problem is that it's hard for nature to make a whole universe. It's much easier to make fragments of one, like planets. Yourself may be in a spacesuit, or even, in the most absurd and troubling example, a naked brain floating in space. Nature tends to do what is easiest from the standpoint of energy and probability. And so these fragments, in particular the brains, would appear far more frequently than real full-fledged universes, or than us, or they might be us. Alan Guth, a cosmologist at MIT, who by the way is the inventor of inflation theory and is a rock star among cosmologists, who agrees this overabundance is absurd, pointed out that some calculations result in an infinite number of free-floating brains for every normal brain, making it, quote, infinitely unlikely for us to be normal brains, unquote. Cosmologists call this the Boltzmann brain problem, named after the physicist Ludwig Boltzmann. Basically, according to secular cosmology, it's far more likely for us to be disembodied brains floating in space than for the universe itself to be real. As two cosmologists wrote, "It is very surprising that we find the universe around us in such a low entropy state. In fact, the logical conclusion of this line of reasoning is utterly solipsistic. The most likely fluctuation consistent with everything you know is simply your brain, complete with memories, fluctuating briefly out of chaos and then immediately equilibrating back into chaos again. This is sometimes called the Boltzmann's brain paradox." Now sometimes people get confused about the Boltzmann brain paradox because they think the paradox is about size. They think that according to the Boltzmann brain problem, a brain would be easier to make from a fluctuation because it's smaller than the universe is. Actually, that's not what the paradox is about. In fact, the Big Bang model says that the early universe would have been much tinier than a brain anyway. The paradox comes from mathematical probability. Even if you're a secular cosmologist who believes that a universe can pop into existence from nothing, the Big Bang model is still so mathematically improbable that a brain popping into existence from nothing is far more probable. Notice I'm not talking about this, a brain floating in our universe. But this, there is no universe. The cosmos is empty other than the brains. There are no galaxies, no stars, no planets, no sun, no Earth, just brains. In fact, cosmologists can't even be sure that there's more than one brain. You might be the only one. Maybe everything you think you see in the world around you, everybody else that you think you know, are all illusions. You're not really watching this video, because this video doesn't exist. Even though you think you're watching it, the input you're getting from your senses is an illusion. And even though you think you have memories of watching it up until this point, those memories are actually false, because your brain just popped into existence a few seconds ago. In fact, your entire life, from growing up as a child until now, didn't happen either, because all your memories are false. Your brain just happened to pop into existence with all the molecules arranged in such a way that it included all these false memories built into it. Oh, and by the way, you aren't going to live long, because your brain doesn't actually have a body to sustain it. So you'll die soon, and then your brain will dissolve back into the thermodynamic soup that you originally fluctuated from. Again, this might sound ridiculous. Well, that's because it is. But that's what the secular cosmological models say. In fact, cosmologists have had the Boltzmann brain problem in one form or another for a long time. And they have written lots of articles in the scientific literature trying to solve this problem and trying to escape the menace of the Boltzmann brains for the Big Bang model. But despite their efforts, the problem has actually gotten worse instead of better. Cosmologists have realized that eternal inflation, dark energy, and the multiverse all lead directly to Boltzmann brains. As long as any one of these things remains part of the Big Bang model, and they're all essential pieces of it, then the Big Bang model says we're infinitely more likely to be Boltzmann brains than normal people. As these physicists wrote, a typical observer in the multiverse is a Boltzmann brain. In the eternally inflating vacua, observers are infinitely more likely to be Boltzmann brains than honest folk like ourselves. Now let me be clear here. I'm not saying that cosmologists believe that we're Boltzmann brains. They don't, because the idea is clearly absurd. But they're being inconsistent, because that's what their model says. The whole situation has become so ridiculous that some scientists are complaining about it. As one wrote, modern cosmologists have a favorite default theory of the universe, labeled lambda CDM, where lambda stands for the cosmological constant, which refers to dark energy, and CDM for cold dark matter. In other words, lambda CDM is just a complicated nickname for today's version of the Big Bang model. Now back to the quote. What we're pointing out is that lambda CDM, the current leading candidate for an accurate description of the cosmos, can't be right all by itself. It has a Boltzmann brain problem, and is therefore cognitively unstable and unacceptable as a physical theory. So what does all this mean? The Big Bang theory, when taken to its logical conclusion, means we're probably not real people. We're probably just Boltzmann brains. Remember, it's infinitely unlikely for us to be normal brains. This means that the universe we see is an illusion. It doesn't really exist. And since a universe which doesn't exist never had a beginning, this means there was no Big Bang. In other words, the Big Bang model ultimately says that the Big Bang is infinitely unlikely to have happened. And that means that the Big Bang model has self-destructed, because it's self-refuting. The Big Bang model disproves itself. So what can we learn from everything we've seen in this video? Several things. First of all, I hope it's clear that the debate over creation versus the Big Bang is not a conflict between religion and science. Many secular scientists try to portray it that way, but they're deceiving themselves. Is the biblical account of creation supernatural? Yes, of course, but so is the Big Bang model. Both accounts are supernatural. Both views are, in effect, based on miracles. So this conflict is not a clash of science versus religion. It's a clash of two faith-based worldviews, two different ways of looking at the universe, both of which have faith in things that are beyond empirical verification. The difference is that the creation worldview is far superior to the Big Bang worldview. The universe had a beginning, and the creation worldview explains how it began. The universe looks exceptionally fine-tuned. and the creation worldview explains who the fine-tuner is. And most importantly, the creation worldview is based on the Bible, which not only has its own authority as the Word of God, it's also well supported and well documented from history. On the other hand, consider all the problems within the Big Bang model. The model has accumulated a towering stack of bandages and rescuing devices, including inflation, dark energy, the multiverse, and much more. Even many secular scientists recognize that it's an ugly mishmash held together by band-aids, just a folktale constantly re-edited to fit inconvenient new observations. The Big Bang model is supposed to be based on the evidence, but instead it requires a big stack of excuses to explain away the evidence. It claims to be scientific, but instead it contradicts the foundations of science. It denies the supernatural, but instead it requires supernatural explanations. The Big Bang is not only bad science, it's ultimately based on hypocrisy. Despite all this, the Big Bang model is still promoted and pushed in Western culture as being the truth. Among atheists, it's overwhelmingly the most popular explanation for why the universe exists. And since atheists are getting more and more vocal today, let's end this video with a brief discussion of atheism and the universe. We've already seen that atheists who deny the Creator and trust in the Big Bang model instead can't explain why the universe exists. Nor can they do good science, at least not while thinking and acting like atheists. Nor can they ultimately even provide any reason for wanting to do science in the first place. It's ironic that many atheists claim that they can find joy in discovering more about the cosmos. As Bill Nye the Science Guy has said, "There's a question that troubles us all from the time we are first able to think, and that is, where did we come from? We are driven to pursue that, to find out where we came from. The joy of discovery, that's what drives us. To us, this is wonderful and charming and compelling. This is what makes us get up and go to work every day." Many atheists have feelings about this that are clearly quite religious. For example, Carl Sagan used to say things like this: "Our feeblest contemplations of the cosmos stir us. There is a tingling in the spine, a catch in the voice, a faint sensation, as if a distant memory, of falling from a great height. We know we are approaching the greatest of mysteries." But what joy of discovery can an atheist really have? According to atheism, there's no reason for the cosmos to exist. It's all a meaningless accident. There's no real interest to be found in the things it contains. Everything within it is ultimately just rearrangements of the original hydrogen and helium gas. To an atheist, a galaxy or a nebula ultimately isn't much different than the air inside of this jar. And atheists can't even protest that these objects are beautiful, because according to them, beauty is meaningless too. According to evolution, our sense of beauty is just a biological impulse, something to attract animals to each other, to drive them to breed. And what's the point of discovering anything about the universe anyway? For an atheist, the ultimate fate of the universe is death and eternal darkness. If there is no God, then in the future, after enough time has passed, every star will eventually burn out. Every source of heat will cool off and dissipate. Everything that's alive will die. The universe will be dark, cold, empty, and completely sterile. If there is no God, then ultimately nothing matters. If the universe formed from a random Big Bang, and then humanity evolved by natural processes, then we're just a cosmic accident. There's no reason for us to be here, and so there's no purpose in our existence. Pain, death, and suffering are our fate, and there's no meaning to any of it. As atheist Richard Dawkins has said, "In a universe of blind physical forces and genetic replication, some people are going to get hurt, other people are going to get lucky, and you won't find any rhyme or reason in it, nor any justice. The universe we observe has precisely the properties we should expect. If there is at bottom no design, no purpose, no evil and no good, nothing but blind, pitiless indifference." And as one evolutionist wrote, "The universe is as deaf to our joyful dancing as to our lamentations, and nobody out there in the immeasurable expanses of the cosmos will bemoan the end of humanity." To an atheist, the vastness of the universe shows that we humans are utterly insignificant. As Carl Sagan wrote, "Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe, are challenged by this. Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves." And as atheist cosmologist Lawrence Krauss wrote, "We're just a bit of pollution. If you got rid of us, then the universe would be largely the same. We're completely irrelevant." If atheism is true, then our lives are meaningless and pointless. If there is no God, then the laws of physics say that the universe will eventually become completely sterile. Just as a hot cup of coffee cools off until it reaches room temperature, so every source of usable energy in the universe is dissipating, and will continue to do so until there's no energy available anywhere to sustain life. Not only is humanity insignificant and irrelevant, our species will eventually be extinct anyway, along with all other life on planet Earth or anywhere else. Even if there's alien life out there somewhere, it will die too. As the universe slowly cools into a permanent total freeze, the entire universe will be completely sterile, completely lifeless, forever. There will be nobody to remember anything that anybody ever did. As one author wrote, "In a universe with this ultimate fate, human existence itself is nothing but a meaningless accident, and humans are isolated in an indifferent and incomprehensible universe. There is no room for anything that has value for humanity, no room for consciousness, joy, sadness, or hope." And as atheist Bertrand Russell realized, even more purposeless, more void of meaning, is the world which science presents for our belief. That man is the product of causes which had no prevision of the end they were achieving. That his origin, his growth, his hopes and fears, his loves and his beliefs are but the outcome of accidental collocations of atoms. That no fire, no heroism, no intensity of thought and feeling can preserve an individual life beyond the grave. That all the labors of the ages, all the devotion, all the inspiration, all the noonday brightness of human genius are destined to extinction in the vast death of the solar system, and that the whole temple of man's achievement must inevitably be buried beneath the debris of a universe in ruins. Only within the scaffolding of these truths, only on the firm foundation of unyielding despair, can the soul's habitation henceforth be safely built. And as physicist and atheist Steven Weinberg has said, the more the universe seems comprehensible, the more it also seems pointless. For the atheist, there was no meaning or purpose for the universe at the beginning, and there will be none at the end. So when you hear atheists talk about the universe with words like beautiful, amazing, awe-inspiring, remember that they're using words that are inconsistent with their atheism. To be consistent with their atheism, they should be describing the universe and our role within it with words like futile, purposeless, meaningless, hopeless. Now contrast this to the joy of the Christian who looks at the cosmos. Christians can have the joy of discovery and have it be meaningful, because the heavens declare the glory of God, and it is exhilarating to discover more of the cosmos and to see more of the stunning beauty of what the Lord has made, rejoicing in His creativity. Christians can expect the universe to be orderly and accessible to science, because our Creator made the heavens and earth to operate according to ordinances which are our joy and privilege to discover. Christians can affirm that human life has meaning, and every human life is valuable, because every man, woman, and child is made in the image of God. And Christians can understand that even though there is much pain and suffering in the world today, this is not permanent, and it wasn't part of God's original plan. Death, pain, and suffering came into the world as a result of man's sin, and ultimately, they will be removed again at the end of this age. Even the vastness of the universe is not a cause for feelings of insignificance and despair, but a cause for joy. After all, who created all this? It was Jesus. By Him all things were created, in the heavens and on earth. All things were made by Him, and without Him nothing was made that was made. Yet He also humbled Himself and took on human form. He became one of us, dying a horrible death on the cross. He did this because we have all sinned and fallen short of the glory of God. He did this because in our sin and rebellion against an infinitely holy God, we had incurred a debt that we could not pay. He did this because only by taking the punishment for our sins upon Himself, only by serving as a substitute and dying in our place, could we receive redemption and forgiveness for our sins. To accomplish this, Christ submitted Himself to untold pain, humiliation, and suffering for our sake. Why? Because He loves us, and there was no other way to save us. And here's our final thought. How much did the creation cost God? Nothing, for For our omnipotent Creator, it was only a trifle. Genesis 1:16 implies that the creation of all the stars in the universe was a mere afterthought. But how much did your salvation cost God? The life of the Son of God, a very high price indeed. And Jesus paid this price willingly, to redeem you and reconcile you to Himself. So rejoice. The size and scale of the universe do not show your insignificance. Instead, the vastness of the cosmos, this awe-inspiring, wondrous universe that made the angels shout for joy at its creation, should remind you of the far bigger love that Christ has for you. May it be that whenever we gaze out into the heavens, so full of wonders, that we are reminded of their Creator. May it be that each time we are reminded to glorify our Creator and to praise His wonderful name. And may it be that each time we are prompted to give thanks for His abundant mercy and grace, and in all ways to faithfully serve Him. Amen.